All right, so this is 6.1. We're looking at constant and percent change, constant percent change. And starts off, you deposit $3,000 into a savings account with an APR of 5.6% and complete parts A through C below. So compute the amount of interest you gain after 1 year. So this is going to have us starting off with the formula for your simple interest formula. A equal to P times R times T, wherein P is your principal, which is your deposit or loan. R is your rate in decimals, and T is your time in years. You know, if that time in years would change, then they will let you know, but I believe everything you guys receive will be in years. And so I is your interest earned. All right, so they gave us $3,000, 5.6. So said $3,000. Rate is 5.6. So don't forget to convert that to a decimal. That'll be 0.056. Time is a year. I should have erased all that, but it's all good. So you just talking about putting 3,000 times 0.056 times a year. And that's $168 will be your interest earned. All right, so that would be what, 168, I think so, that's all right, yep. And say round to the nearest dollar, make sure you pay attention to that. Some will tell you, and we see it right here, 3 decimal places. Some will say round to the nearest cent, some will say round to the nearest dollar. So make sure you pay attention to that. Here it says compute the amount of money in the savings account at the end of 1 year. Take the original value, add interest, which is 3,000, then plus the 5.6% times 3,000. So the way you would do this, it says what is the equivalent to multiplying 3,000 to multiplying by that 3,000, talking about that factor. And actually that 3,000 represents 1 or 100%. And then it's plus that 5.6%. So really it will be 1.056. We got that 0.056 when we multiply it by the deposit, earlier in our formula. So really is 1 plus the 0.056. And that will be the same thing as that factor. So whatever your rate is, convert to a decimal and add it to 1, which is like adding it to that 100%. And that will be it. Here to fill out the chart, notice it says the beginning balance is 3,000. That's what we deposited. We already said after 1 year, it was going to earn $168. Then that means you add those together to figure out how much money is going to be in the account after 1 year. So that's 3168. All right. So now to fill out the next one, you start off with 3168 at the beginning of year 2, because that's what you had at the end of year 1. Then we throw that 3168 back into the formula. So we do 3168 here. Do the calculation. Let me check on something real quick. Give me 1 second. All right, sorry about that. Attend to that. So we have 3168 times at 0.56. So it should be 177.408, 77.41. Went around to the nearest cent. Then we add that. And that's how you would do that. And then the next one, you do the same thing. You start off with 3345.41 and then plug it into the formula and continue with the same pattern. All right. So let's go to the next one. Here's the same thing. You got 3,100. Annual interest 5.6%, 5 years. So you plug that into the same formula. All right, here is when we have something a little different. So we got Suzanne deposits $5,000 in an account that earns simple interest at an annual rate of 2.5%. Then we have Derek, 5,000 at an annual rate, or a compounds interest at an annual rate of 2.5%, and it's compounded annually. So notice one is at simple interest and the other one is at compound interest. So that means we have to use a compound interest formula. The one we were using before was just simple interest. So compound interest formula is right here. A times P, A is equal to P times 1 plus R over N raised to the N plus T power. So I'll just emphasize that N, I say N plus T, N times T power. N times T is an exponent. So make sure you're careful with that. So that's an exponent. P is your principal, R is your rate, which is in decimal, T is your time in years. Now N is the number of compounding periods per year, and A is your future value. So this one gives us the future value that will be in the account after however many years. Remember before, we just calculated what I was. So if I want to know what I is, the interest earned, I would do my future value minus the amount that I deposited, which is my principal. And so that's what I was emphasizing right here. A minus P will always give me my interest. My future value minus the principal will always give me the interest earned. Excuse me. And so N being the number of compounding periods per year, to let you know how many times your account had interest applied to it within a year. All right. Then when it comes to compounding periods per year, they don't give you the exact number most of the time. They just tell you or give you a keyword that lets you know what the number is. So annually means N will be equal to 1, semi-annually, and N is equal to 2. Quarterly, N is equal to 4. Monthly, N is equal to 12. Weekly, N is equal to 52. And then daily is 360, not 365 because of Banker's rule. So Banker's rule just states that you use 360, so 365. All right. So when we look at our problem, let me see if the numbers change. Looking at they got 2.5. I guess I'll change it to 2.5. So we are depositing $5,000 at 2.5% interest. Derek is compound annually. Okay, so do these numbers over. So they both are depositing 5,000. They both have a rate of 2.5%. Just that Susie is simple interest, Derek is compound interest, and Derek is being compounded annually. That means n is equal to 1. So let me plug in these values. Uh, 0.025, so it's 125. And so if I want to know how much money will be in the account after 1 year, it'd be 5125. So when we go back, let's see. So I could get my mute button off. All right, so for Suzanne's annual interest is 125, and then the balance would be 5125. All right. Now for Derek's, we have to use a compound interest formula. So we'll plug in this accordingly. I'm not mistaken, it's still gonna be 5125. So 5,000. All right, so that's 1 year. Yep, 5125. So that's 5,000, 1 plus 0.025 over 1 raised to the 1 times 1. And so those are the variables, pulling from that formula. 5,000 is P, R is 0.025, N is 1. Then we have N times T as our exponent. All right. So 5125 is how much he earns after 1 year. So go back to the homework. Interest is 125. That's 5125. And notice they both had, after the first year, they both had the same thing. And what we're going to notice is when we look at the pattern, we're going to do it for all 5 years, or when you do it for all 5 years. Of course, I won't do all 5 years right now. When you do it for all 5 years, you start to see the pattern that simple interest is going to earn the same amount for Suzanne, but Derek's is going to change a little bit. So let's go to year 2. All right, so for year 2, 5,000 times a 0.025, and then that's times T, which is 2 this time. And so that should be 5,250. All right. 250, 125. All right. So as far as year 2 and Suzanne is concerned, she's going to earn $250 interest. In year 2, you add that to, if you were talking about after 2 years, she would add $250 interest. So it would be $5,250 that would be in her account after 2 years. So if I want to know how much she earned between year 1 and year 2, I would subtract them and I would see that it would be 125. So if I go back to this, interest earned would be 125, and then the balance after 2 years would be 5,250. All right. So like I said, from year 1 to year 2 and year 3 in the simple interest, you'll see that's going to be the same. But when we look at this next one, so year 2 or after the second year for Derek, put a 5 right here. So there's 52, 53.125. And if I'm not mistaken, they want to round to the nearest dollar. So this one is going to be 52.53. So then I would do 52.53. Try to stay consistent with my colors. And we have 51.25. So it's going to be 128. All right, so go back to our homework. So it'll be 128 right here, and then 52.53. And so what's going to end up happening is we're going to see that the simple interest is going to stay at 125, but the compound interest, and you see it already started to go up $3. And as it continues to go, towards that 5th year, the interest earned per year is going to increase. All right. So questions before we do another one? All right, so let's look at another one. Compound interest formula, accumulated balance, I just did. So it's the same type of thing, but make sure, once again, you pay attention to whether you're using simple interest formula versus a compound interest formula. Here we have $6,000, 6% interest for 5 years, compounded annually. Oh no, I lost my spot. What's going on? Let's just do this. So yeah, it would be this formula right here, 6,000. Let me go back to the actual thing. We got 6,000 at 6%. So it'll be 0.06 here, and then it says at 5 years. And it's compounded annually, so n is equal to 1. And so you would just plug that into the calculator. So make sure you know how to use your calculator when you're talking about jumping into this section. All right. Questions on that one before we go to the next one? Stated compound annually. Deposit for the same thing. Let's y'all mess with that one. Okay. So this one right here is a conceptual question, so I'll let you read that one. Because it's only one right answer, and they don't even give you multiple chances. So when you go do it, read it, and they'll give you an understanding. But here, the difference between linear and exponential. So your linear is going to increase by a number. Notice right here we're increasing or decrease. Increase or decrease it by a number. Here we're increasing or decreasing by 6 or 7. So that's going to make it linear. The difference is, notice here, it increases by a percentage. So that's going to make it exponential. All right. Once again, if it's increasing by a regular number, that's linear. If it's increasing by a percentage, then that's going to be exponential. And I keep saying increasing because that's what I see. Same thing when it comes to decreasing. You know, if it's decreasing by a percentage, then that's exponential. If it's decreasing by a number, then that's linear. All right. So let's go here. Population of towns increasing by 607. So like I said, it's linear. State whether the growth is linear, exponential. Okay. So now, what would the population be in 4 years? So in 4 years, right now the population is 1,600. In 4 years, it will be us adding 607 to the population right now 4 different times. So you can multiply it times 4. 607 times 4 is 2428. And then add that to 1,600. And I'm going to split up. And that's just going to be 4028. So once again, we talk about linear. You're going to take that number that they give and increase that current number however many times that they tell you to increase it to. So once again, you're talking about 1,600, and we did 4 times 607 because it was 4 years. All right. Questions on linear? All right. So the next one. So next one is exponential, as I mentioned. And now, so this one takes a little more calculation, but not hard calculation. It says during the worst periods of hyperinflation, hyperinflation in a certain country, the price was increased. Now, once again, I want to emphasize the fact that in both of these problems, they were talking about increasing. If they asked you to decrease, or if it was mentioning decreasing, then we would have subtracted. So in that last problem, if it was going to decrease by 607 per year, then we would have minus 607 4 different times. Okay, so that's the difference between increasing and decreasing. So the price of the food increased at a rate of 10% per month. All right, 130. All right, so let's look at increasing 10% per month. And ours is 130 to start. And how many months did they say? Yep, 3 months later. So we're going to take 10% of 130. 10% of 130 is 13. And it's going to increase, and we're going to increase it by that 13. As I stay with my blue. So that's 143. We're going to do this 3 times. So then we'll do 10% of 143. It's 1430. Then we'll take that 143 that we had from the last month and add 1430 to it. So that's 158.30. Then we take 158.30. Take 10% of that. 1583. And then we're going to add that 158.30, going to add 1583 to it. So And that'll be 174.13. Yeah, 13. Yeah. And this asks for us to round to the nearest dollar, so it should be 174. All right, I must have missed one of my numbers. Let's make sure. 43 plus 14.30. I wrote 158 here. I should have wrote 157. That was my fault. So 157 here. So that means there should be 157 here. Should be a 7 here. So 157.30. 7, so 157.30 plus 15.73, and that'll be 173.03, which is just 173. All right, so I was off by $1. Yeah, so I'm good to go. Yep, messed up with that one digit, but the process is, still the same. All right. And if I'm not mistaken, those are the last problems out of that section. Yep. So questions on anything that I've done out of 6.1. Any questions? Any questions? Okay. So that's it for today. Like I said before, this is what we're looking at doing to close out our new lecture. So it means really so on Wednesday will be our last day of, well, it depends on how we move in these two sections. But the plan is to get through the notes for chapter 8 next class. But if not, we can always do it on Monday. It's not a big deal. Finish it up on Monday. It's not a big deal. But 8.3 will be the last new set of material that you guys will be held accountable for. All right. Questions, concerns, or comments before we close this morning? All right, good. Everybody straight. Okay. Well, you guys have a good day. Stay safe, and I will see you on Wednesday. Take care.